All right, guys. Again, wanted to record a video of how I solved this particular problem. So again, in this problem, it is asking us to solve for what is this tensional force. So a couple things we want to do from the get-go is just establish, okay, what variables do we know in this particular problem, and what type of motion are we seeing here? All right, so a couple things we've established in this question. We know the mass is going to be 5 kilograms. We know that the force at an angle is 30 degrees. It does give us the coefficient of kinetic friction, which is 0.3, and we're trying to find the tensional force. One other thing, once you've defined your variables and draw your free body diagram, which we're already given, is determine what type of motion do we have. So in this problem, we know that the object is moving in the x direction and is moving with constant speed. Now, that's important, right? It's important to know if we're moving with constant speed or if we are accelerating. If we're moving with constant speed, that does tell us that the net force is going to be 0, which means that our frictional force is going to be equal to our tensional force in the x direction. Now, this gives us a clue here because what we can do with our tensional force is, while we can't solve for it directly, what we can start doing is we can start defining, okay, we don't know what it is at this angle, but we can determine using some algebra what the force components are in the x and the y direction. So we have tension in the x direction, tension in the y direction. In order to solve this, let's set it up as an equation. All right. What we get is we just get a simple right triangle here. So tension in the x direction, we have an angle of 30. So if we want to solve for this, this would be the same as our tensional force times cosine, right, because it's the adjacent side, 30. In the y direction, right, same thing, right? It's going to be our tensional force. This side is the opposite side, so it's going to be sine 30. So this means that our frictional force is going to be equal to T cosine 30. We also know that our frictional force is the same as that equation for friction that we found in our previous class, which is frictional force equals mu times normal force. All right, now, normally, normal force would be equal to our gravitational force because they're opposite. However, in this problem, our tensional force is pulling up a bit. So, in fact, our normal force is not going to be completely equal to mass gravity because it's not just sitting flat on the table. It is being pulled up a little bit. That doesn't mean it's moving up. It just means that some of the force opposing gravity is going to be contributed by this tensional force in the y direction. So what that means, I'm going to set this up a little bit separately, is that our normal force is going to be equal to our force of gravity minus the tensional force in the y direction. All right, if we want to find normal force, it's going to be gravity minus the y component of that tensional force. Another way to write this would be normal force equals mass gravity minus T, sorry, it's supposed to be sine, T sine 30. So we can define that here, that our frictional force is going to be equal to U, mass gravity, T sine 30. All right. And that is going to be equal to T cosine 30, because that's equal to our frictional force. So pulling this together, we get T cosine 30, which is a tensional force in the x direction, is the same as mu mass times gravity minus T sine 30. Okay, so we've established that our frictional force is going to be equal to our tension in the x direction. And we know that our frictional force is going to be equal to mu times F norm, which is the same as mu times mass gravity minus tension in the y direction, which would be T sine 30. So we can establish this formula. And from here, what we can do is we can just work out some algebraic steps in order to solve for our force at a angle. All right. So one thing we can do is rearrange this a little bit. All right, so we're going to get, let's factor this all in. So we get T cosine 30 equals U mg minus T U sine 30. All right, let's we're going to move this over to this side. So we get T cosine 30 minus T U sine 30 equals U mg. Now we can factor this out. We get, so it's 3 plus, we get factor out T, right, because this is ultimately what we're going to solve for, equals cosine 30 add an extra parentheses in there for no reason. Oh no, that did have a reason, right, because we factored T out, plus U sine 30 equals mu mg. Now we can divide both sides by cosine 30 plus mu sine 30, and this will allow us to solve for tension that's at the angle. So we get UMG divided by our cosine 30 plus mu sine 30. From here, we can just plug in all the numbers that we know. So T equals 0.3, that's our mu, times 5, that was our mass, times gravity, it's a constant 9.81, divided by cosine 30 plus 0.3 sine 30. Really need the parentheses. All right, and then from here we just calculate it all. All right, from here we know all the numbers that we need. You end up with a tensional force of 14.47 newtons. All right, so let's do a quick look back at our steps. tensional force equals 14.47 newtons. So here's the fun thing about this. We didn't actually need, at no point do we actually solve for the force in the x direction or the force in the y direction. We didn't need to. A lot of this was just plugging in our formulas and then rearranging them all the way until we could solve for our tensional force. All right, so we started by establishing the variables we know, figure out the type of motion that we have, constant speed, which means that net force is 0. That makes things a lot easier. If net force is 0, that means our frictional force is going to be equal to our tensional force in the x direction. We know our formula for friction is going to be mu times normal force. In this case, normal force is going to be mass gravity minus the tensional force in the y direction. All right, then from here, it is just rearranging our equations until we're able to get T, our tensional force, by itself. So you notice at no point do we do any calculations. We just did a lot of rearranging. Until we get to our final equation, which was tensional force equals mu mg divided by cosine 30 plus mu sine 30. At that point, we're able to plug in the numbers and then simply calculate. So again, may be helpful to take a look at all the steps. Hopefully I wrote clear enough for you guys to see. If you guys are having additional questions here, please let me know. Happy to help you. Once again, this is my thought process. Some of you guys might go through this a little more smoothly.